Okay, we will now switch to English as our next speaker hasn't learned Swedish yet, right? He's learning a few words, but today he will speak to us in English, so I will also present him using the English language. Today with us, we are very happy to have Bernie van Leeuwen from SKF. He is the Program Manager, Machine Learning and Prognostics at the SKF Group. As I told you earlier, I'm quite interested in the history of all the different industries and the people that are coming here today. And SKF, well, it's quite old. It's more than 100 years old, and it started in Gothenburg on the 16th of February 1907. And the name was Aktiebolaget Svenska Kullagerfabriken. Det låter jättefint tycker jag. Vilken fantastisk industrihistoria. When I looked at your webpage yesterday, I find a video that I could recommend you guys. It's called Living Vision. And sometimes you might find that industries, is that a creative business? But what they did that really made me interested in SKF is they connected it to dancing. They had a ballet dancer, and by showing how the ballet dancer uses her or his body to actually move with perfection to achieve the best dancing results, is the same with the machines, and to be able to control them. So, in this presentation, you will learn how digitalization is being used at SKF in order to realize their vision. And their vision is a world of reliable rotation. So, now we will learn how digitalization has enabled SKF to provide even more value for their customers. Welcome, Bernie.
So first of all, I'm not sure if I should make a promise that if I ever come back that I will try to do this in Swedish, but I promise you that I will at least make an attempt in trying to learn Swedish. I moved here in August, and so far so good. I really enjoy it here. Thank you for having me here. I'm excited to talk about what digitalization actually means for SKF. And I also just saw from the previous speaker that it's really about also tangible examples. And when I was starting to prepare for this day and started to think about how do I try to make digitalization and Industry 4.0 a little bit more attractive and a little bit more tangible, and try to look for an example that probably everybody would recognize. Because if we talk about digitalization and if we're talking about sensible things that communicate, which is one of the words that I did catch from the Swedish speaking person before me, I actually put up a picture here from Formula One. And this is not because we just celebrated in SKF 70 years of strong partnership with Ferrari in Formula One, because this is actually a competitor, as you can see. But this, I think, is a very clear example of how digitalization can help customers, can help end users, can help basically people that have a responsibility for a certain asset to perform, how you should use information in order to take the maximum performance out. And the reason why I say that is because it's very easy to think that the strategy of this operator, as you could call him, that his strategy would actually be to just go as fast as possible, take the maximum output from that expensive asset that he has, and not worry about basically any maintenance or reliability of his machine. But then he will probably have a lot of nervous colleagues actually in the pit, the guys from the maintenance department. They need to make sure that whatever the driver is doing to the car somehow gets fixed. And then there's an element which is normally in the background, and this is, I think, where really the digitalization kicks in. And you see these guys here staring at this screen. And they are continuously monitoring what's going on. Oil pressures, tire wear, anything that would actually influence the reliability of that asset. And that's basically the analogy that I would like to start my presentation with for today. If this driver, if this operator would not continuously have the information that is being given to him from these guys, if he would not be connected with his asset to these guys, he would probably not be able to get the maximum performance out, which again does not automatically mean that he has to push always the pedal to the metal. No, this is a matter of optimizing different pieces of information and balancing also between maintenance, reliability, and of course the maximum output that you can actually gain. Having that said, I hope that sets a bit of a framework of what I will try to explain to you today. I will try to show you how the products and the services and the offerings of SKF are actually affected by digitalization, but also how we have been using digitalization inside SKF to make progress and to actually be better prepared for this Industry 4.0. I'm pretty convinced that I probably don't have to introduce SKF as a company here in Sweden, but I will give it a best shot anyway. As already said, we are founded in 1907. That means that we have more than 100 years of experience when it comes to the manufacturing and the engineering of bearings and rotating machinery. We have a turnover of 80 billion Swedish crowns, and we have 45,000 people all over the globe. And I can really say we are a truly global company. You can see that by the presence in 130 countries, and you can also see that we have a very strong connection and a very strong partnership with our distributors, basically making sure that we are present in more than 17,000 locations all over the world. That also means that in our communication to customers, to end users, our distributors actually play a very important role. Our vision is a world of reliable rotation. This goes, of course, much further than probably what most of you know SKF for, the bearing. For sure, the bearing plays a key role in the reliability of rotating equipment. But all the knowledge that we have gained in the past 100 years is, of course, absolutely key to help our customers to keep the machine running. And we can only do that by being actually the undisputed leader in the bearing business, in the way we manufacture bearings, in the way that we support customers also in keeping the machine running, lubrication systems, sealing solutions, sensing technologies, but also a lot of software development, making it insightful for end users, trying to understand where actually the reliability would actually fail. And this is one of the this is what is the connection to Prognostics that I carry as a responsibility in the company. To make sure that we also can upfront actually make sure that customers know when actually certain maintenance action is actually required. And that, of course, comes with a lot of requirements on knowledge and sharing that knowledge also with our customers, and make sure that the knowledge also gets embedded into the software and the services that we're actually providing. So how do we do that? It's always customer first. So everything we do is driven by demands and needs from our customers. What is giving the customer sleepless nights? What is the customer trying to do? So we're trying to create, in everything we do, create and capture the value that customers are actually looking for. Then it's very important that all the developments that we do, that these are application driven. We clearly see in the market that there is a demand for value driven innovation, not always doing the next step in performance as such, but make sure that you address the specific needs of a customer. And I will also give you an example with that. I can even tell you what the link will be towards digitalization. Of course, world-class manufacturing. A bearing is a very standardized product these days. You can actually find the ISO rules around how bearings are basically being defined. So you need to be absolutely strong and world-class in manufacturing to make sure that you make these components in the right way and to be actually competitive in the market. And that goes, of course, also for being cost competitive, making sure that we provide the value in the most efficient way and eventually make sure that that, of course, maximizes the cash flow over time. What I will try to tell you today and try to actually make a link with is how digitalization actually fits with these 4 and 5 priorities that I've actually been displaying here, and how digitalization is currently still changing SKF as a company in everything that we do. You're probably aware that the Internet of Things, or the Industry 4.0 revolutions, as some people call it, is really the 4th in a row. So where we started to actually use mechanization, water and power and steam, going actually to and actually enabling mass production, setting up assembly lines and making sure that we use electricity to actually speed up the output. Then, of course, we had the automation in the 3rd revolution, where computers and automation kicked in. The first machine monitoring was being born, and of course the plant maintenance started to play an important role. Instead of fixing something when it was broken, we saw the benefits of actually starting to plan the maintenance and to take care of the reliability of rotating equipment. And now for sure, with the Internet of Things, and where basically everything gets connected, it gets much, much easier to get much more data and to find much more correlations that would even much earlier tell you when you would actually run the risk of losing the reliability of your machine. But it's not only digitalization. I believe that digitalization is a trigger for a lot of industrial changes actually going on. And I'll give you some example. You may understand that as SKF, we're supplying original equipment manufacturers, but for sure also end users. And we see basically changes all over there. So if we look at our business with OEMs and OEMs that have a clear service strategy as well, is that what I was just saying is that there's a clear differentiation in performance. It's not only a matter of providing the best performing product and trying to innovate on that field. No, there's also a clear shift towards what we would call value offering. Is this product exactly suitable for the purpose that I have as a customer in this field? Which you can imagine is for a bearing a very difficult thing to do. You might think that after 100 years, the only thing that you could still do to a bearing is basically improving its performance, increasing the steel quality, increasing the life. But that is not always required to actually meet the requirements of the application. Then, of course, we see that there's a lot of disruption in the distribution, especially when you take it as a channel for going to market. You see the growing power of an Amazon. You can imagine that as a company where we are very reliant on our distributors to take care of those 17,000 locations, it's very disruptive that at some day we have to think about that Amazon might be one of those distributors as well, with a huge global reach. Well, what does that mean for our partnership towards our distributors? And of course, end users. It's not only the efficiency and quality that they actually provide. They're also asking their suppliers, even if we would be only supplying the bearings, the lubrication systems, and the seal, and some of those related services, they're asking us actually to move much more towards also performance-based thinking. And I will give you some examples of that in this presentation as well. So what are the two, you could say, value propositions that we put into the market as SKF? Well, as I said, many of you probably know SKF from our product, but we also put these products into the market in what we call a rotating equipment performance offer. And this is where we take much more, you could say, responsibility almost for the reliability of a rotating machine. Again, all that knowledge that we have over the past 100 years on how machines perform, why do machines fail, how can you make design improvements. This, of course, you cannot always capture only in a product offering. This is what we're also trying to capture in our rotating equipment performance offer, and I will try to explain you a bit better what that actually means. So let's focus on the product first, and especially how does digitalization actually affect the way that we put the product into the market, how we put this value offering into the market. A product offering these days means that you need to be able to supply the right product for the right cost at the right time. So that goes already far beyond the product design as such. You need to make sure that the product gets there in time, and you need to make sure that you have optimized your product for actually the application requirements, looking also from a cost perspective. And again, a bearing being a standard component, it's not only a matter of continuously improving the performance. And this is basically what you see here depicted, and I'll show you some other examples later on. It's not only an innovation, a matter of trying to bring the value up and trying to increase the performance. It's also a matter of trying to see, are there elements in my design that basically this customer may not be willing to pay for? In other words, is that maybe an opportunity to bring the cost down? And if you combine those two, this is really what we have actually defined as value innovation. And you can imagine for a standard component like a bearing, where we have for the last 100 years been driving the performance of those products, this is quite a new thinking. I'll give you an example from the metals industry. This is a very high demanding applications. It's of course very critical. We're talking about cold rolling mills for automotive steels, very high quality standards that need to be fulfilled there. And it's basically a high-speed aluminum mill that we're actually approached for to design a bearing for. Of course, the customer needs were increased output, for sure bringing down the maintenance cost, and of course, increase the reliability in such a way that there would not be any unplanned stops. Just to give you a ballpark figure, if there is an unplanned stop and maintenance needs to be basically organized on the fly, we are on average, depending probably from industry to industry, we're talking about 5 to 7 times more cost in terms of doing an urgency maintenance than if this would actually be a pre-planned type of activity. So you can imagine that the cost, and I'm not even talking about loss of production, but the cost for having to do maintenance that is unplanned is really much bigger than if you would actually be able to properly plan this. So reliability is absolutely key. In this case, we're talking about quite a special product. It's a 4-row cylindrical roller bearing. I will not bother you with the details, but it's quite difficult already from a design point of view to actually get out the performance that you actually need, let alone that you can adjust and make sure that this design actually directly fits with customer needs. Just to give you another example where reliability of the product is absolutely key. We're talking about frac pumps. Frac pumps have to work. You cannot actually allow for the frac pump not to work because you can imagine that the time that the pump is not working and the standstill that it actually creates basically means that you have a loss of money because of loss of production. You have to deal with extremely high pressures, so that means high loading conditions. There's a very contaminated environment, and you have to deal with poor lubrication conditions. So you can also see that these requirements, apart from the high loading conditions, are pretty different than what I showed you in the previous example. So what we've done is we have very carefully looked at what are exactly the requirements for this application. And for example, if there is a specific planned maintenance interval of, let's say, every 6 months, then why would we try to strive for a product that would last maybe 6 years? This then opens up an opportunity to think of some elements in the product, some performance elements that you could basically maybe take away to take away cost, to maybe focus that on other performance criteria in order to make a very specific design for these type of applications. Now, why is that connected to digitalization, you may ask? Well, the reason for that is if you start to turn a standard product into something that is very much dedicated to a specific application, then of course the volume will by default be much smaller. And then basically all the effort that you may have taken to take cost out might basically be lost. In our more traditional manufacturing, that would for sure hold. But if we now look at actually the completely new manufacturing, and this is really a state-of-the-art manufacturing site now here in Gothenburg, which we actually inaugurated in April this year, where basically everything is fully optimized, everything is robotized. And the most important thing is that it actually takes out the resetting time. And now all of a sudden it becomes interesting, because if I have basically 0 resetting time, then this equation of the volume that I manufacture versus the cost basically gets a major shift. To give you another example, and this is of course more for the future, if we see at a customer application that there might actually be a bearing failure coming up, you could basically connect that to this manufacturing site, and basically the bearing will reorder itself. The robot will start manufacturing as soon as it gets a signal that the bearing is actually failing. Now that sounds a little bit futuristic, but you can imagine that digitalization and the integration of ERP systems, operating data, maintenance data would eventually enable this. You can take out a lot of trigger points which are currently actually, for example, leading to a lot of stock. The end user has stock because something might break down. Then we have a distributor that also keeps products in stock. Then SKF has a huge warehouse keeping parts in stock. Why do we keep that all in stock? Because we don't know when something is going to fail, because we are not combining the data that will actually allow us to take this stock out and basically manufacture whenever it is really needed. So the opportunity is really big. Then if I go back to the 2 value propositions, and we focus on rotating equipment performance, I think there that value proposition is much more, I think it's probably much more clear what we should be doing there, what we are doing there in terms of digitalization. As I said, this value proposition goes basically beyond, you could say, the transactional selling of bearings and bearing related products. This is really about us selling the bearing function more than actually the bearing as a product. So instead of waiting for a customer to place an order to replace bearings, or placing an order because he has developed a new machine, which basically leads to peak, of course, in the ordering, in the stock levels, also in the expenditures that customers actually have, we basically make an agreement on the performance that our products are actually given. So instead of now our innovation being a way to improve the performance of a specific product, now our innovation is all of a sudden steered by customer needs in terms of reliability, output of their machine, reduction of maintenance cost. And then you really have application-driven innovation. We call this concept rotation for life. It's also built on a performance-based type of agreement that we will then have with end users. And you can imagine that this also comes with a lot of additional risk. If you sell a product that sits in a box, the moment you sell the product, you're basically stepping away from the risk. For sure, you have guarantees, you have warranties, but basically that's as far as basically your business risk goes. If you're now saying, I'm selling you a function which I ensure you will lead to a certain manufacturing output, then of course you can imagine that the business model has completely changed. And then we're not even talking about the purchasing price of bearings anymore. No, we basically, based on the performance that we have achieved, we will actually be paid for the performance that we have actually also delivered. And there, of course, in order for us to reduce that risk, we need to heavily rely on the data that we're actually gathering. We need to look for correlations in order to reduce that risk, in order to understand why a machine is actually failing. I'll give you an example just to illustrate this. A conveyor belt may not be the most interesting application from a technology point of view, but it's of course very critical to move goods, or basically half products, from A to B. So the reliability of such a conveyor belt is extremely important. Now, what we have done here is that instead of continuously coming in and selling products once maintenance actually needs to take place, we have taken full responsibility for the functionality and the availability and reliability of this conveyor belt at one of our customers. So we have equipped it with real-time automated collection and analysis. We have automated it so far that basically there's no staff involved in order to actually get the data in. We're using full history and trending, which we can also use, for example, to make design improvements. And of course, we make a link to all kinds of corporate data systems. Because now that you're actually equipping this conveyor belt with a lot of sensors, it's not only for the maintenance. You can also see how many kilograms of goods have I actually moved. How has that impacted basically reliability? What was the relationship towards the overall output of that factory or site? But there's another thing, and this is what I meant with application-driven innovation. Because we also saw that the lubrication of this conveyor belt was actually done manually, which first of all is also a reliability risk, because how do you control how much lubricant was actually added by an operator? And should these lubrication conditions not be dependent on, for example, the loading condition, on how often the machine was actually used? So it became in our interest, in order to ensure and take away the risk and increase the reliability, to install an optimized lubrication system in this system. Therewith, eventually, of course, also reducing the overall operational cost for the customer. And this is, I would say, the clearest example of how it has led to also product innovation, is that we also learned that contamination was an important issue in the reliability of this type of machines. So we started to develop basically a spherical roller bearing, which is here, that is actually completely sealed, in order to again increase the reliability on the basis of the experience that we started to gain also from these type of applications and pieces of assets. If we talk about industrial digitalization, then what is it that we actually refer to? I was trying to give you that in the previous example. But in SKF, we have a definition where we say it's important to collect the data. And let me be correct, because data is, of course, something else than information. Data is not easy, is not difficult to get, but to actually turn data into information requires, of course, some intelligence. That data you first need to connect, and then there needs to be some kind of a detection. A lot of systems are basically collecting data all the day, but they're not always connecting. They're not always throwing the data somewhere where it needs to be processed. That would basically be a waste of bandwidth and a waste of time on that end. Then the second stage would basically be to analyze the data that has been collected, to diagnose, so to understand what does it say about the condition of the equipment, what does it also say about the severity of any faults that I may have found. And if I know the potential fault and if I know the severity, then I can also start making predictions. I can use, I think today we will also have a speaker about artificial intelligence. Well, for sure, when we talk about prognostics, we're talking about statistical models, we're talking about looking for correlations. So we will for sure use also historical data in order to find those correlations and to make better and better prognosis on when we think actually the reliability of a machine will no longer meet basically the requirements. Way before, of course, we have a full functional loss of that piece of equipment. The nice thing about this split up is that you can basically, in rough terms, say that the first part is normally taken care of by sensors and hardware. And this is also where in SKF we are heavily investing. You can imagine that for a company that has been making bearings for the last 100 years, the balance between having software engineers, having people that can actually develop applications, that can understand data mining, versus the amount of people that know everything about material science, tribology, these type of competences, that balance is still, I would say, quite onto one end. And I will show you later on also what that means, because we should really realize that this is an industrial revolution, which also comes with a lot of changes in terms of competences and knowledge. And I think that was also what you were addressing in the beginning. So this is basically what we do, you could say, on the analytics side and on the software side. You could also say this is how we go from data to information. If you don't analyze the data, then it's just data, then it's not information. Then as soon as it becomes information, then you can start making decisions. And then it is really important that you have started to think about your customer, because your customer needs to make decisions every day. This Formula One driver is making probably 60 decisions a minute. Maybe every second he needs to make an important decision. Can I accelerate or not? And he's using the information from the guys that are looking at the screen and are basically turning the data into information for him. And a good decision, of course, always leads to an action. And if we talk about predictive maintenance, this normally means corrective actions. So in terms of plant maintenance, but also in terms of supply chain. Should I actually check my stock level right now? Because I know that something is actually going to fail in a few weeks' time. What are the competences and the support and the service that I need to actually maybe rebuild one of the machines in order to avoid a reoccurring failure all the time? Maybe I should even re-engineer the machine that I have on my site. And of course, there also needs to be operational decisions. Is it better maybe to turn down the speed of the machine 5–6%? I know I will actually have some loss of production, but if I can therewith avoid a major unplanned stop, then that might be a financial trade-off that I would actually make. And these type of trade-offs, of course, requires information to be available on the operational side, on the maintenance side, and on the reliability side. As I said, this also means that the focus on innovation and technology development within SKF is changing a lot. In order to collect, connect, and detect, we need to, of course, focus on local sensing. And you may already have seen that in the past 15 years, we have been doing condition monitoring in SKF, and we have quite a strong project portfolio when it comes to to condition monitoring. But we also see that when it purely comes to sensing, the competition in the pure sensing side of the word is actually very fierce. Connecting also means that all of a sudden we need to be able to tap into completely other systems that actually would give us, for example, operational data. It's not only sufficient now anymore to look into vibration data. We need to couple that with speed of the machine, loading conditions. If you think of a food and beverage example, maybe you want to know the moist level of the product that I actually put in the machine, so I can find a correlation with how fast that machine was actually breaking down. Of course, on the analysis, as I said, we need to use software for doing the prognostics and making sure that we take statistically correct conclusions from the data. And last but not least, connecting eventually everything also from a supply chain perspective. If we have this data up front, then we should take the benefits from taking out stock levels and taking out all the capital that is basically in there, because there is uncertainty about the events that are going to happen. And by taking away that uncertainty by looking into the data, we should for sure also look at what can we integrate in the supply chain in order to take that capital basically out. So how do we envision this from a product perspective? As I said, we have at least 15 years of experience in SKF when it comes to condition monitoring. But it also means that the developments have been very much focused on experts that know how to turn the data into information. That's of course great if you are monitoring 400 wind turbines somewhere. But if it is your ambition in 3 years' time to maybe do 4,000 wind turbines, should you then hire 10 times more experts that can actually go through those signals and read it out? No, you have to use different technologies to actually look into that. It's also a way of visualizing. Why does the expert have to pick up the phone and tell the customer, listen, you have a problem in this and this machine, or you might have to plan for this, this, and this. By connecting the data directly to automated processing and diagnosis, we can directly display basically the reliability and you could say the risks that an end user or a customer is basically running into. And this is where we'll put the data together. So it's a matter of looking at our existing systems, existing products, and how we actually bring them all together in what we call SKF Enlight Center. This will be actually a center in which operators and maintenance customers will be able to see the status of their machinery. And if you think about software development, then you can also imagine that the customization of this interface is also extremely important. Because if you are responsible as a fleet owner in marine for several ships, you probably want to have the data shown to you in a different way than when you are the reliability engineer that basically does the measurements. You are basically interested then in which are the measurement points that I need to take in my ship in my next round, whereas the fleet owner basically needs to optimize the planning of the ships as such. So also there, the existing products that we had did not allow for that type of flexibility. Were not made, you could say, for the new revolution that is going on when it comes to also visualizing the data and again helping our customers to make operational decisions. So that's on the collecting side, and we're of course also working on implementations that would actually not yet require us to have the full-blown digital revolution taking place. If I think about our quick collect sensor, it's one of the technology that we will be using, for example, in our partnership with distributors, where we basically give them the sensor. There's a very simple app on your telephone, and a distributor can go to a customer. He will basically place the sensor onto the machine, and on his app, he will basically see, is it red, green, or amber when it comes to the reliability of the machine. So all the analysis, everything basically takes place in your iPhone. And that distributor, that basically certified partner for us can then basically make the decision and give a good recommendation for that customer. And that of course will help us eventually also in the product sales, don't get me wrong. But that's of course a win-win. It's a win-win for us as SKF, and it's a win-win for the customer where the knowledge is basically brought directly through our distributors to our customers. For sure we're working on Also sensing technologies in more harsh environments. I think you will hear a lot more about mining soon as well. And for sure, mining is one of our areas where for sure reliability is extremely key. So that is for sure also one of our, we're also talking about railway applications, marine applications. And we should not forget, it's not that we want to replace, of course, our experts with optimized technology. No, it's a matter of scalability. Again, if you want to do things in a much broader way, you need to look for smarter ways to do things. And again, the Industrial Revolution, the combination of data is allowing us to do that. So digitalization, as I said, is enabling a world of reliable rotation. And what does that mean in terms of opportunities? As I was saying, what we are doing already today in our cooperation with our dealers, for example, is providing them the possibility to go to their end users. I mean, you can imagine that even though we are with 45,000 people in SKF, we cannot cover every customer. We cannot actually go and monitor every machine that is out there in the globe. So we need to provide also our distribution channels, our dealers, with very easy to use equipment where the knowledge is already embedded in the software and where basically the hardware is very easy to use. Just to give you an example of how we are already using current technologies, but for sure also the thinking on how the world would further develop from a digitalization point of view, how we're actually using our products and putting actually products out there that will help us prepare better for the future. Then a marine example. As I was saying, the interface and the decision making is absolutely key. Think about customers, think about the decision that that specific user of the software is actually making every day. So in our Enlight Center platform, we have been working on a very simple interface where, depending on, for example, something simple as your login, you will see a different analysis. You will see different information that will help you in making your specific day-to-day decisions. There will be one interface. So if it is required to combine vibration and maintenance data with operational data, we will make sure that we actually make that part of our development. And of course, we will provide that also as a cloud solution. I think everybody is nowadays used to working in the cloud, storing their documents, storing your photos. And this is for sure something, of course, that will also enable us to be better at integrating and basically making combinations of data and information. It will for sure mean a step up when it comes to condition-based maintenance. And that is, of course, why we are doing this, in order to bring up the level of reliability, in order to bring down the maintenance costs that are normally related to rotating machinery. That also requires a completely way of developing things. Where traditionally you would first start to gather design requirements, you would make a long list, you would look at the functionalities, and you would actually make a coupling to product features. If you're working with a software interface, it's extremely important to understand what this user will eventually do. What does he want to see? So we're using the Agile and Scrum approach to actually work in sprints to predefine the specific needs from a specific user in order to move things forward. To give you again that example for marine, there's a huge difference between a fleet manager that needs to basically manage 6 to 100 vessels with reference to a chief engineer who's typically responsible for 1 to 5 vessels. Their target is also different because a fleet manager will typically want to optimize the overall maintenance cost, and a chief engineer basically wants to avoid surprises. So really a loss of function is for a chief engineer on that specific ship maybe even more important than the overall risk that the complete fleet actually is running at. So this is also why we have hired a lot of additional software engineers in Gothenburg the last couple of years. And the first thing that they basically do is they go out to customers and they try to understand what is it, what type of functionality, what type of visualization, and what type of data should I actually represent in order to help them in their decision making. We have recently launched a first segment pilot in the marine, and so far so good. I think especially for a traditional bearing company, I think launching a platform like this, you can imagine, is a huge task. But I think the approach that we took And the feedback that we have received so far from these different users within the same segment, I think has been very encouraging for us to move on. And it's also confirmation that the direction that we have been taking as a company is for sure the right one. To take it even to a higher level, digitalization also means cooperation. It also means for sure that you will have new competition. If SKF starts moving into the software direction, then you can imagine that we will engage with new competitors. But for sure, there's lots of opportunities in cooperation, especially if we come from the maintenance and formation data side, and we want to combine it, for example, with operational data. We have actually, and there was actually a press release, I think, at 8:30 this morning, where we've actually started to connect very strongly now with Honeywell, in order to combine, you could say, the best of both worlds. Combining operational data with the maintenance data, combining the knowledge from Honeywell and the infrastructure knowledge that they can provide, and of course the knowledge on rotating equipment performance from SKF side, is leading eventually for a customer for much better reliability and a much better output of their site. So in Chile, there is a huge copper mine that we have basically started to work together on with Honeywell. And as I said, you still see experts, you still see people in the control room. But it was unthinkable that the people from Honeywell and the experts on the operations side and the maintenance people would actually sit together also with the experts from SKF. And now that you see the displays, and you probably recognize the picture that I started off with. I mean, these guys are running a mine. The other guys were running a Formula 1 car. There's a lot of similarities that you can actually find there in terms of performance and in terms of making sure that there is reliable operation. So what does that cooperation basically mean? As I said, it's the condition monitoring data and the knowledge on rotating equipment performance that we combine with Honeywell's process data and of course the operational performance in general that they are in control of. And by combining those, I think we really made a very strong case towards the customer to optimize his overall performance of that mine. But I'm sure that Peter can tell you more about that. A final note. As I said, this is really a revolution. This is really a big change. This is not something that will go away. And that unfortunately also comes with big changes. And I've taken, and my Swedish is at least good enough that I can read some of the headlines of the newspapers, I can assure you that. But basically in the same week almost that we unfortunately had to announce that we had to basically replace 160 people. We also had the same announcement that we were hiring 50 new people in the software area. So with all these changes, not only in the development and the way that we bring our value to our customers, but also in our internal operations, in our manufacturing, there are so many changes going on that unfortunately it also means that we have to change the competences and the people that we actually have. Fortunately, it leads to a lot of new opportunities. As I said, we have been hiring the first 50, and we will for sure be hiring more and continue to invest for sure in our value proposition when it comes to our core products, but especially, of course, also in our rotating equipment performance, all to basically make sure that our customers can actually rely on the machine that they have and work on a vision to have a world of reliable rotation. Tack så mycket for your attention.
Thank you so much, Bernie. Do we have a question from anyone in the audience right now? Yes, we have one over there.
Yes.
Wait for the microphone. Yeah. You can repeat the question, please.
My question was, in which areas do you apply machine learning or applications do you use for?
Yeah, so when we talk about condition monitoring in order to detect potential failures early enough so that we can actually do something on the severity, we use machine learning in all three stages of the, you could say, the condition monitoring analysis. So it's of course to detect that potentially something is wrong. We use machine learning, of course, to make a connection to diagnose in terms of what is the potential root cause failure of this detection or of this alarm, and what is also the severity that actually takes place. And you can do that, of course, by using pattern recognition. You can do that by using historical data to basically go from an unsupervised learning type of methodology and to add labels basically to events that you have seen in the past. And then the next step would, of course, be to do the proper prognosis. So if you have the severity level and the diagnosis done in the correct way and a reliable way, you can also use machine learning or other statistical mathematical techniques to also give a prognosis on what's the likelihood, what is the statistical likelihood that actually this probable failure will end up basically in a full functional failure. So machine learning as such covers the whole train from initial detection to providing a prognosis on when a machine is very likely to fail. I do have to say that since this is a very much data-driven technique, you need to be absolutely sure that what you're doing statistically makes sense. And this is, I think, where we are, of course, using our 15 years of condition monitoring experience, where we have been using, you could say, more analytical techniques in terms of frequency spectra, in terms of overlays, FFTs, you know, the more traditional ways of looking at condition monitoring, and actually combining them with machine learning techniques and new mathematical and statistical techniques to actually do that. So I think it's especially the combination that makes it strong to actually move that forward. Does that answer your question?
Do we have another question? You talk about the revolution. Obviously, this is a revolution for a company who has existed more than 100 years. This is a big difference. I have also studied your vision, of course, and the mission of your company, but also your company values.
Yes.
And two of your values are about teamwork and also openness.
Yes.
How important are these like basic values for you when you work with data, information, and the new digitalization era?
I would almost say I kindly invite you to come over to Gothenburg.
Thank you.
And to enter the office of our software development team, because then I think you will feel, you will see, you will smell what teamwork basically means. Because it goes into simple things like how you even set up an office environment, how you allow people to quickly jump to a place where they can actually cooperate. So yes, this is an extremely important part. If you have to work so closely together and combining different competences to get something done, yeah, you basically have to drive that value, especially within the company, of course. So yes, those are for sure, those will continue to be extremely important drivers, independent from the revolution that's going on in the outside world, basically.
Yes. Okay, any more questions? Yes, we have one over here.
Yeah, you talk about openness and the access to data, which is the key to make this analysis. And my company we have working with information in the forest industry for quite a long while. And when the first enthusiasm is a little bit, the first week has passed, you always come into discussion regarding who is owning the information.
Yes.
Because it can be quite sensible for a supplier to own information on the customer's equipment.
Yep.
It can also be used for negotiations and so on. So how do you consider the ownership, and what discussions have you had with the customer so far?
Yeah. No, I think this is, I fully recognize this difficult discussion. For sure, everybody wants to do something on sharing data and wants to do something on IoT as such. But then when it comes to sharing data, when it comes to cybersecurity, when it comes to, no, I don't want to move to the cloud, then the enthusiasm normally dims in a little bit. I think we have to be aware of the fact that if you don't do anything at all, you will actually get disrupted. Because if you imagine that, take the example of the Formula 1 driver. Imagine that there is a Formula 1 team that would not have those guys sitting at the screen. And they would not be using basically this radio technique, which is probably also sensitive, you know. It would be very interesting to see what another team is doing. Then you would basically not be able to win the race anymore. And I think that awareness still needs to find a place. For sure, we're not there yet. So we're also always trying to make a customized approach. It's a matter of cooperation, as I also said. So it's also understanding why certain concerns are still there. When it comes to ownership of data, I think the right question would be, what is the information that you want to take from the data? Because the data as such might be not so sensitive, but of course the information that you withdraw from the data, which is sensitive. And I think that is the right discussion to have. Which data do you actually need access to in order to provide the information that you were looking for? But I agree, it's a delicate balance in terms of who owns which data, and that will require also some additional thinking on how we're going to solve that in the industry, absolutely. Yeah.
Okay, thank you so much. I will give you a little present, thanking you for joining us today. So thank you so much.
Thank you.
Really interesting, and I also know that Bernie will be here for the rest of the day as well, so you can catch him during lunchtime or when we have fika.
I'll be happy to answer your questions.
So, big applause. Thank you.
Okay, thank you.